During this demo, we'll be spinning up a remote workstation environment with GPU acceleration on a HPC cluster. On the screen, you can see a terminal session which is monitoring a traditional HPC cluster environment and using Slurm as the workload manager. On the bottom screen, we have a number of queues configured within the environment. For example, this visualization queue, which is used for the nodes that are accelerated with Quadro GPUs. And on the top screen, we are running the SQ command that shows the jobs that are currently running, and right now we see this is empty. On the left, we have the LMX cluster dashboard, which is an alternative graphical user interface for users that are not comfortable with command line tools. We'll begin the demo by moving files to and from the HPC environment. The GUI includes drag and drop capabilities to make this and other file manipulations as easy as possible. In the Jobs menu, we can monitor the active jobs that are running, and we can see that similar to the terminal, there are no jobs listed. If you do need a shell terminal, this is also available by the GUI navbar. One of the applications that we want to demonstrate today is LMX's remote desktop capabilities. Under the Interactive Apps menu, we can select Remote Desktop, and we get presented with a simple user form where we can specify the time we require the environment for. Once launched, we can see in the right-hand terminal some activity appear. We now see our job with ID of 183 submitted by our support user and allocated to node 9, which is one of the nodes on our visualization queue. We can also confirm this in the GUI by viewing the active jobs pool, where we also see the time limit versus the time used. In the GUI, we can see that our job is in a running state and we are presented with a Launch Remote Desktop button. This tunnels all of the output onto the compute node that we have been allocated from the comfort of the browser. If we load up a terminal on the remote workstation, we see we are logged into node 9 directly, and we have a local Quadro card configured and ready for use, as well as an NVIDIA PCI device locally attached. We can quickly and easily load up some typical visualization applications, for example PowerView. Once loaded, we can see in the background that it has detected the Quadro card, which it will use for graphic acceleration. In the application itself, we can open a sample file, make some 3D manipulations to it, and if we go back and switch on the monitor function in the shell, we can actually see in real time the GPU utilization metric jump up and down. With LMX, you can enjoy GPU-accelerated 3D visualization from the comfort of your desktop, safe in the knowledge that with the timing feature, your resources are returned to the general pool when they're not needed. We can see once we have finished our work and deleted our job, the job is now in a completing state and the nodes have returned to idle and can be allocated to alternative user jobs. To find out more about LMX features and use cases, visit www.define-technology.com. Thanks for watching.